welcome MongoDB Senior Vice President of Field Engineering, Richard Kreuter.
Ain't no rest for the wicked until we close our eyes for good. Yeah.
Good morning, everybody. Hey. How's everybody doing today? Well, I want to welcome all of you here to MongoDB.local Dallas, to everybody here in Theater 2, also our friends over in the next room in Theater number 1, and for everyone who's watching the live stream. Good morning, afternoon, evening. If you're watching the live stream, it could be any time of day for you. So for those of you here at the Alamo Draft House in Dallas, we've got if you've been to the Alamo before, there's these little cards in front of you where you can write down your order. Don't do that. We're not bringing you any food during this session. There'll be lunch after the keynote at lunchtime. And really excited to have all of you here. We've obviously got a big day lined up. How are the morning sessions for everyone? Yeah, good. Anybody learn anything good? Awesome. I'm glad to hear that. Well, we've got a whole lot of more stuff, content lined up for you for the rest of the day. I do want to make sure everyone knows that those of you who are here, please check your inbox. At the end of the day, we'll be sending out a survey for feedback, and you need to complete that survey in order to pick up all the swag over at the registration room out in the hall. So please do keep an eye out for that at the end of the day. We do want your feedback to make sure that we can make these events more and more exciting as we go. All right, without further ado, I'd like to kick off the keynote and welcome up to the floor, not the stage, VP of Engineering at MongoDB, Will Shulman.
Thanks. Thank you, Richard. Thank you. Thanks, everyone. My name's Will Shulman. I'm a VP of Engineering at MongoDB. I was more recently CEO and co-founder of a company called MLab. We were doing database as a service for Mongo. Some of you might know us. We were recently acquired by Mongo, so really excited to be part of the Mongo team. And I personally am really excited to be here in Dallas. We've got a really great program today, really fun keynote, lots of cool demos from other members of the team that are going to come up and show you some cool stuff, all around why MongoDB is the best database for modern applications. And I know it's a big claim, but this is what we're going to focus on today. And let's talk a little bit, take a step back. Modern applications, what does that mean? There's a lot of ways you could define modern applications. At MongoDB, the way we like to think about it is, what do modern applications demand of their tech stack? What do modern applications require? And one of those things, something we're somewhat obsessed about at MongoDB, is called developer productivity, right? So you guys as developers are most likely one of the most scarce resources in your organization, probably the most valuable resource in your organization as a result, right? So making you guys productive so you can get apps out quickly, so you can get user feedback, iterate on features, all of that is really key to building a modern application. The second thing is infrastructure agility. So what does that mean? Well, you ask yourself questions like, can I write my app that works with one user and scale that to 10 users, hundreds of users, thousands of users, millions of users, without having to rewrite my application code or change my infrastructure? Or can I develop my application on the laptop and then go run that application maybe in a private data center on hardware that you own, or run that same application in a public cloud, change public cloud providers, all without rewriting your application? That's infrastructure agility. And finally, modern applications require uncompromising user experience. So you want your applications to be fast. Your users expect it to be fast, not just for if they're in the same country where you host your infrastructure, but they expect it to be fast all around the world. They expect things like real time. So gone are the days of hitting reload in your browser to see data update, right? When you update data in a database, your users expect that data just flows through the rest of the services that use them, and those updates happen in real time. So these are all the things we think about when we think about how to help make MongoDB the best database for modern applications. And really, when we talk about it, we think about three architectural pillars of MongoDB that are really quite unique. The first is the document model. The second is the fact that MongoDB is a distributed database and makes use of all sorts of sophisticated distributed systems concepts. And third, that MongoDB runs everywhere. So I'm going to talk about all of these today. And through the talk, I'm going to talk about why MongoDB is the best database for modern applications in each of these three areas. So let's first talk a little bit about the document model. So unlike a traditional database, we have tables, and those tables have rows, and those rows have columns, and those columns have scalar values like instance strings. MongoDB stores JSON documents as its kind of unit of data. right? And that's huge. If you're a server-side developer, it's very likely that you're spending a lot of time, most of your time, wrangling JSON, writing REST APIs, taking JSON off an API, trying to put it in the database. You're obviously using an object-oriented programming language if you're doing anything modern, right? So in that context, we believe that the document model is the most natural way to work with data. The second interesting thing about the document model is this idea of a dynamic schema. So in a traditional database, you have to be very upfront about what columns your rows have and what types they are. And you can certainly do that in MongoDB as well. You can be very, very prescriptive about how your data looks. But you also have some flexibility and some dynamism in your model. This is great for when you have to add features, iterate with features fast. Sometimes you add a new feature. It's got some new fields. You don't want to necessarily go update all the old documents because it doesn't matter. Or anywhere in your code where you're doing something, maybe in your programming language, you're doing something polymorphic. You have like a superclass and subclasses you want to represent in that database. That kind of polymorphic thing, really, really great for dynamic schemas. And then on top of this great model, you have this query language that intimately understands the document model. It understands that you might search and sort for fields that are deeply nested in arrays or subdocuments. And you have a query language that lets you sort and search and filter and do all sorts of aggregations, and we'll go into some of that later today. Okay. So the second thing that makes MongoDB somewhat unique is that it's a distributed database. And this affords you all sorts of interesting behaviors that you don't get in a single node database. The first is high availability, right? I think we've all learned to expect hardware failure. It's how you react to it that matters, right? So having a node fail doesn't mean your application goes down. When you have high availability in a multi-node cluster, your workload should fail over to other nodes and your application should stay up. The idea of scale out, right? With a single node database, you're kind of limited to how much RAM, CPU you can pack into a single chassis. Scale out, or horizontal scaling, if you've heard that term, allows you to grow your cluster by adding more and more nodes, and you can grow MongoDB clusters to very, very large data sets and very, very heavy workloads. Next is this idea of workload isolation. So in MongoDB, you have a distributed cluster. You can actually say, these nodes are for these workloads, these nodes are for these workloads. How many people here have had the experience of you've got your app, it's running on top of your database, everything's fine. Maybe some business analyst kind of innocently comes in and runs a really complicated query that just takes your database to a grinding halt, affects your application, brings down your, yep, he had that happen. So workload isolation, right? Workload isolation, you can say in MongoDB, this node is for analytics, and you're guaranteed that none of the queries that run on that node are going to affect your live app traffic. And then finally, there's this idea of zone sharding. So zone sharding is this idea that you can build these global clusters in MongoDB, and you can write rules that say certain data has to live in certain locations. And this is really fantastic for giving low latency access to users around the globe, and also to comply with regulations that might have rules that say certain data needs to live in certain places. The third architectural tenet of MongoDB that's really, really interesting is the idea, and this is very explicit on behalf of us who've architected, is it's got to run everywhere, and it's got to have this ubiquitous experience, right? So all these features I talked about, it's not like, you only get high availability if you run in a certain cloud provider where we're using their disk replication, blah, 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 right? No. All of these things are built into the core of the database so that you have a consistent performance, consistent experience, whether you're running on your laptop, in the public cloud, in the private cloud. And this is important because this gives you portability, right? This gives you the ability to move your workload from one place to another without having to rewrite your application. And then finally, any database deployment, any IT department, any engineering organization that's deploying a database has to think really hard about how you secure that data. And one of the nice things about MongoDB is it's got such a sophisticated security model built in with role-based access control and all sorts of other things that security model that you define doesn't have to change depending on where you're running MongoDB. You don't have to define one security model on-prem and a different security model, let's say you're running on AWS. So today we're going to talk about all the ways, in the last year, let's say, that we've been working to make improvements to MongoDB in each of these three areas. And to make MongoDB what we believe is a truly horizontal platform that's great for any use case, for any modern application. So let's start talking about the document model and what we've done in the document model to help make MongoDB the best database for modern applications. So it'll come as no surprise to you if you've been following our releases that in 4.0 last summer, we released something that we've been working on for a long time, multi-document ACID transactions. And you might ask, if you're a Mongo user, you might say, well, I thought the document model allows me to store all the related information to an object inside that document itself, so I don't have to spread my data amongst multiple tables. And while that's true and reduces the needs for when you need multi-document transactions, there are still a lot of really interesting use cases where transactions are really helpful in MongoDB. So I'll use an example here. This is from, let's say, an e-commerce application. You've got your order, right? So an order is here defined as a set of line items. And this is what you're maybe doing in a checkout. And what you want to do in your code is you're going to save that order to the database. And then you're going to go through each of the line items in the order, and you go to another collection, an inventory collection, and then decrement the inventory on that so you don't oversell. But what happens if your code were to crash, say, right there or right there? What would happen is your database would be left in an inconsistent state, right? You will have updated the order, but you wouldn't have updated the inventory in a corresponding way. So transactions are meant to solve this problem. So in MongoDB, the way you would solve this is you'd use a transaction. It's very, very simple. You'd start a transaction, and then you'd go do all the stuff you want to do, passing that transaction ID through to all the database operations you're performing. And then at the end, you're going to either commit that transaction or you're going to roll back, which means that either all of this stuff is going to happen or none of it's going to happen. And therefore, you're not going to ever be in a state where your data is inconsistent. All right? So let's talk a little bit about these transactions and what makes them similar to anything you've used before. Like if you've used a relational database and you've done transactions, this should be very familiar to you. We haven't invented some new type of NoSQL transaction. They're very familiar, same model you've seen elsewhere. They're conversational, so you say start transaction, you do all of your logic, and then you end the transaction or you roll back. So you do some reads, you do some writes. Those writes are based off those reads. Very, very familiar. And then most important, or maybe not most important, but very important, is that they're fast. And let's talk about that for a second. So it's really important when we build transactions to make sure of two things. One, if I have a non-transactional workload, right? I'm doing things without transactions. Have we done anything to the core database to make it fundamentally slower? We want to make sure that didn't happen. So we have this benchmark here. It's called the Socialite benchmark. This is a benchmark you can download. It's open source. You can run it yourself. And what it does is it's meant to simulate all of the interactions you might have in a social networking application. And so this benchmark right here is showing a bunch of scenarios comparing 3.6 before we had transactions and 4.0 when we added transactions with a non-transactional workload. So we're not using transactions here, and we want to see, did we make anything slower? And the good news is, in almost all the scenarios, MongoDB is at least as fast as it used to be. And in scenario 1, it's actually quite a bit faster. Right? So check mark, we haven't done anything inherently stupid for the base case. The second test is obviously, what is the overhead of using a transaction? Right? There's got to be some overhead, but how much is there? So in this case, we did a comparison. And what we do with this benchmark is we save two friends, right? And friends obviously point to each other as friends, and it's a symmetric relationship, so you don't want to have one pointer go one way and not the other way. So something you might want to wrap in a transaction. And one test is when you don't wrap it in a transaction. The other test is when you do. And as you can see, there's a slight overhead, but somewhat negligible. It's about 2.5%. And the way computers are getting faster and faster, almost every month, we saw that as a win. That was a good result. So if you're interested in learning more about how to benchmark transactions and just talk about transactions in general, I'd invite you to go to Asia's talk, 2 p.m. in Theater 1. So let's talk a little bit about roadmap. Right now, in 4.0, full transactions with replica sets. 4.2 is where we're releasing transactions with sharded clusters. So if you want to use transactions with sharded clusters, you have to wait a little bit, but that's coming in 4.2. And we've been working on this for quite a while. So it's not like we woke up one day and said, oh, we should add transactions to MongoDB. We always knew this was going to be something we added. It really started with MongoDB 3.0. Where we created a new storage engine called WiredTiger. Actually, we acquired WiredTiger. WiredTiger was a storage engine that was out there that was a really great fit for MongoDB. So We brought it in-house. We started using it in version 3.0. And as you can see, we list out all these features here. Most of the features needed for transactions have already been used in previous versions for other features. And as you can see, we're putting on the final touches now for full distributed transactions and sharded clusters. So if you're interested in this, you can actually download 4.2. You can play around with it. We wouldn't recommend it for production yet, obviously. But this has been the roadmap, and we're on the home stretch. OK. So let's talk a little bit about when you should use transactions, right? Just because you have a shiny new toy doesn't mean you should use it all the time. And for this example, I'm going to go back to our orders data model. So this is an example of an order data model that you might see in a traditional relational database, where the order and the line items are actually separate in separate tables with pointers to each other, right? Well, because you have transactions in Mongo, you could actually lift this data model and kind of clone it in MongoDB and have a collection for the orders, a collection for the line items. And then using transactions, you could actually make sure that you update them both atomically, right? But this is not what we would actually recommend. And the reason is because even though you could do it, we think you want to basically, you have this new way of data modeling. You can use two different types of references, right? In this case, line items really don't have a reason to exist outside of the order they're a part of, right? If the order didn't exist, there would be no reason for those line items to exist. In that case, we don't really think these are distinct objects, and you should embed them, right? And you might wonder, well, am I going to have any issues with updating all the line items in an order, right? You can do that with MongoDB update statements. You're really not going to sacrifice anything for embedding this into the document. So that's how we would say you should do this type of data model. And so, going through how you should think about when you use transactions, really think about whether you have distinct business objects, right? Orders and line items, those are not distinct. Orders and inventory, in the example I showed you earlier, those are distinct. Inventory has a reason to be, even if orders don't exist, right? So that's a great example of where you should use transaction. If you're updating truly distinct business objects, you can model them separately, and you can use a transaction to update them atomically. Another example where you'd want to use transactions is in this case of rollups or views. So imagine you have a stream of time series data coming in. Maybe it's sensor data coming in at a very fine granularity. And maybe you're doing some sort of statistics. Maybe you're basically computing some stats like on the hour or the daily basis that you want to pre-compute. Or you have another application that needs to read this data, and there's this view of the data that's kind of expensive to compute. So you want to compute it as you're writing out the data to make the rest of the application have really fast read access. These are both cases where you might want to do that inside of a transaction. That's a really good use case for transactions. Another use case, this is something internal, right? This is something in 4.2. So in 4.2, we're adding a feature where you can actually change the value of a shard key in a document, right? And when we implement that, the way we handle moving that document under the hood, right? So if you change the value of a shard key, you might have to move that document from one shard to another shard, right? Behind the scenes, we'll use a transaction to do that, to make sure it's done in a consistent way. So if you're interested in learning more about transactions, in particular the distributed transactions that are coming, please go see Ali's talk later today at 1 p.m. in Theater 1. OK. So we added transactions. In and of itself, really, really exciting. For those of you who remember, there's some versions back, we added $lookup. $lookup is basically the equivalent of a join in MongoDB. Joins and transactions are traditionally two of the features that you think of in a relational database that gives it much of its power. And now that we've implemented both of these in MongoDB, we truly believe that MongoDB is the best database for relationships. Let's talk about why. So in a traditional database, you have one type of relationship. In MongoDB, you have two, right? So here's the reference type of relationship, the one you're really familiar with from traditional databases, where you're spreading your objects across different tables and you point to them by IDs, right? You can do that in MongoDB. But MongoDB also gives you a second type of relationship to work with, which we call an embedded relationship. So here, going back to our line items example, these line items are in a nested array, right? And this is fantastic, right? So I can't tell you how many years I personally dealt with object relational mapping and the idea that data is spread out across multiple tables, right? This is probably how you might model it inside of your application code, right? And so the idea that you have to spread things across multiple tables always, and you can't say, oh, this person needs an array of phone numbers. I'm just going to stick that in the object, right? By having the embedded relationship, you have a whole other degree of freedom for how you model your data, which is going to be, in many cases, more convenient for your application and more productive for you as a developer. So we really believe that MongoDB, with both of these features now, is the superior solution for representing relationships between things in the world. OK. So let's talk next about, in MongoDB, how we do more complex querying. Maybe you want to compute some statistics or do some lightweight analytics. For those of you who use MongoDB, the way you do that is called the Aggregation Framework. And the Aggregation Framework was hugely inspired by the Unix pipeline model, right? You've probably all seen stuff like this before. This is an oldie but goodie inside the MongoDB offices. This is a query that shows you how to get all the slowest queries out of a MongoDB database log, right? Something we do quite often. And you can see it's composed of all sorts of small, understandable parts. You're doing a grep, you're sorting, you're getting the last or the slowest, and then you're kind of piping that back through the file to get the full lines. This is something that is, it's probably been around for decades and decades, but it's an incredibly powerful model. And the reason it's powerful is, first of all, it's composable. You can take these very small, very easy to understand chunks of logic, and by composing them together, you can get all sorts of behaviors out of it that are actually quite complex. Also, by being composable, it makes it very debuggable, right? So you might have a very large pipeline of stages, and you might have a bug in it, right? Well, how do you find the bug? Well, it's kind of easy if you can take each one out in isolation, test it, or maybe chop it in half and see, OK, in the first part of this, does the bug come through? OK, no, this part's right. Oh, it must be over here, and kind of very quickly hone in on where the problem is. So debuggable is very important. And then, of course, all of this is incredibly powerful, and allows you to do very sophisticated things using a whole suite of operators that we prepackage for you. And we actually have some new ones I'll talk about. So we've added some stuff for date manipulation, which was really convenient. Allows you to break apart dates into its component pieces, or create dates from component parts like month, year, day. We've also got some new string manipulation operators that let you take apart strings, pull out characters from strings, concatenate them back together. And then, kind of boring but important, the ability to very easily convert between different types. So strings to ints, ints to strings, strings to dates, things of that nature. Here we are with an example of what this looks like in the actual aggregation framework of MongoDB. This is the same thing we were doing when I showed you the Unix example, but just kind of Mongo style, right? We're looking through the logs collection. We're going to sort it by time. We're going to limit it to the slowest 20, and then we might group it by query shape to see all the query shapes that are the slowest queries. And if you look at this and you compare it to what you might have to do, these can get quite long, right? So even though a 20-stage aggregation pipeline might seem complicated, right, it's nothing compared to what the equivalent would be in SQL with multiple pages of nested joins and just right. So, but we thought we could do better. These things, they can get complex to debug sometimes, and we've built this really cool new aggregation builder in Compass, which is kind of a visual tool that lets you both build and debug pipelines in a really easy way. Actually, it's kind of fun. So what you have is, down the left side of this new tool, you can put your stages. So this is a stage, for example, that matches all documents where status is completed. And then along the right side, in real time, the tool is taking a sampling of your data set and showing you the results of putting that data through that stage. And as you add more stages down the right-hand side, data updates in real time and flows through all of the stages. That makes it really easy to kind of see what you're doing kind of outside your code. So you might, instead of just sitting in code and then running your code and seeing if it's right and then running your code and seeing if it's right, you can build your aggregation in here, get it right, and then put it in your code base. Or if you have something in your code base that's really hard to debug, you pop it in here and figure out what's going wrong. So to show you a little bit more of this, I'm going to invite Scott up to give a demo.
Okay, thanks, Will. Okay, as Will mentioned, when you're building an aggregation, the best way to do it is kind of step by step and iterate over the process. So I'm really pumped this morning to show you how much easier that is to do in the aggregation pipeline builder inside of Compass. And that's true whether you're a new user just learning how to build aggregations or whether you're an experienced user that's been doing this for some time. So first, let's recap a couple of the highlights inside of this. So for this particular demo, I'm going to build a new aggregation. Notice that we're in our swag store database and we're looking at our reviews collection. And we're on the aggregations tab. So as Will mentioned, over here on the left is where we'll define our stages. Over here on the right, we'll see the results out of that stage, so we can very easily step through it. So we'll jump right in. We'll build a new aggregation. So the first thing I want to do is kind of look at my documents over here. What I want to do is go into each category and look for each type of merchandise I've got in that particular category. Let's see what my ratings are. What are my reviews like? So we can kind of get a feel for what's popular, what's not. Maybe we can improve our store experience. So let's start over here on the left. The drop-down box here will list all the possible stages that you can use. If you start typing, then you'll see that it narrows the pipelines down to match, or the stages down to match. Let's look at one that's a little more complex. And we'll just select graph lookup. So if we look at this, you'll see kind of two distinct areas that it populated for us. The first down here at the bottom is the actual attributes or parameters I want to pass into that stage to perform whatever function it's doing. And at the top, because I have comment mode turned on up here, you can see that it describes each one of those various parameters, what it does, whether it's optional or not. And if you need more information, you can click on the little information icon up here and it'll take you to the appropriate manual page. So for the purposes of this one, let's go through first and let's filter down the documents. So we're only looking at things that we want to see in our reviews. And most good pipelines actually start with a match. So we'll go through that and we'll match based on category. Now notice as I start typing, it's going to filter down looking at the attributes and fields within that document. So it gives me suggestions as to what I might want. So we're going to look at category. And I only want to see apparel. There we go. And as I finish typing, it'll actually go out, query the database, and show me the results of that particular stage. This is one of the features that makes this really easy to walk through complex aggregations and see the results that I'm going through it. So I'm not making quite as few bugs up front. Okay, so let's jump on to the next one, and we'll group these. So we'll go to a group, and I want to group based on the name. And then we want to calculate out the average stars. So let's just call it average stars. And down here, and then same with the accumulators. As I start typing, it'll narrow down my list until I get to the ones that I want. And there's average. And then we want to look at stars. My bad. And there we go. So we can see over on the right, we've gone through very quickly for each one of the products. We can see the average stars. So we've got some 5s, a couple of 4s. And now I can go ahead and refine this, sort it, depending on how I want to see it. But instead, let's take a little bit more complex. I mentioned before that this is also for experienced developers. And so in a lot of cases, an experienced developer has probably already got some pipelines that they're looking at in a text editor, which is how we kind of developed it old school. So what I'm going to do is go into my editor here. We'll select everything and copy to the clipboard. And I'll go over to my orders collection, which is what we're going to do this against. Now, this particular aggregation, what I'm doing is going through all my orders. First, I want to see all the orders that are completed. Then I want to start, setting the data up so that I can do aggregations against it. I want to group it by month and year. I want to look at categories. I want to calculate revenue, items sold, the amount of revenue, etc. So what we can do there, we simply go in, new pipeline from text. We'll paste the pipeline in, create new, confirm. And you can see that the aggregation builder has split everything out. So all my stages that I had defined up there are still over here on the left. The results are being shown over here on the right. So let's take a look at some of the steps that we're doing as part of this one. So first off, I want to filter. I said before that we typically start with a match stage, so I can go through and filter the documents down to what I want to see. In this case, I just want to see completed orders. And then my products is actually an array, so I want to break that down. So we'll unwind it. And then we'll start getting into the actual meat of the aggregation itself. So in this case, we're grouping by the state, by the year and the month, by the product category. We're calculating out quantity sold, total revenue, and unique products. And if we look up here on the right, we're seeing the results of that. So we continue on with the next stage. And this time we're going to group by state and by year, month. And we want to calculate total revenue, and we want to build the revenue for all the products, by various months. I want to build an array, so I'm taking these previous documents, shoving them into an array so I can have one document per month. But as I'm looking over here on the right, I kind of notice that the year month doesn't look correct. So what I'm seeing is kind of a number format, and what I'm expecting is a year dash month, like I've got up here. So let's go back up to the top and see if we can't figure out what's going on. So let's look at our first match stage here, and we'll start scrolling over to the right. And we can see pretty early in this data set that, I've got ISO dates here. We've got some older documents that have a numeric format that's probably second since Epoch. So since I am using 4.0 for this, I can very easily convert that over to a standard ISO date. So let's just simply add another stage. Now, since I'm using this date created attribute field further on down in other parts of my aggregation, I want to keep the same name. So I'm going to do that by selecting Add Fields, and we'll just give it the same name that we have up here. So we'll call it date created. And we'll go over here, and we'll use the toDate conversion function. So what this will do is take the values, convert it to an ISO date, and we want date created. There we go. And now if we look at the data down here, it looks like these are correct. This is what I'm wanting to see. We got 10,014, 10,014. All right, let's scroll on down to our last group by here. And we can now see the year and the month as I expected, year dash month. So at this point, I can do the thing that all developers love to do. I can just go and type in all my changes back into my code editor and make this thing work. But fortunately, we decided to make it a little bit easier for you. So you can actually go here and export the language. So on the left-hand side, I see the JSON document that represents just kind of the meat of the aggregation, if you will. And on the right, I've got the actual code representation. So we got it in Python by default on this one. Let's take a look at C#. That shows you a little bit more of the code you might have to write if you were trying to actually implement this as part of your application. And if you're new to Mongo, you might want to not know what include statement you need to do. So we'll show you the import statements as well. Now currently we have support for Java, Node, C#, and Python 3. If there's some other ones you want, we invite you to do a pull request so we can know which languages our customers are interested in, and we can focus our efforts on what really matters to you guys. So with that, I invite you to go and download Compass if you haven't already got it, and I'll turn it back over to Will.
Thank you, Scott. So yeah, this tool is a lot of fun. Even if you don't have anything to do, it's fun. So check it out. It's new in 4.0, and we'd love your feedback on it. Okay, so let's keep talking about the document model. So kind of a basic. One other thing you might want to do with your database is write an app on top of it, right? So we haven't talked about app building yet. Let's take another e-commerce example. We call this our swag store. And this might be built in a traditional 3-tier app mechanism. You've got maybe a JavaScript client, whether it's web-based or mobile, and maybe an API talking back to a REST API, implement in the language of your choice. And then that REST API is talking back to a Mongo database. And what we're showing here is this is our user interface for the store. The URL you see above, think of that as kind of the REST API that you'd be using in the URL structure of the REST API. And then finally, up in this box on top, we have the Mongo query that you'd be generating based on what the user tries to do. So here we have an empty query. This is looking at all products. Makes sense. It's kind of the base case. You might want to go filter by category. Very reasonable thing to do in the app. So you can see the way we did that is we've added a query param to the API, cat equals shirts. And then up top, you can see that we've dynamically generated a corresponding MongoDB query. It's worth noting here, how easy it is to dynamically generate queries with MongoDB. You're not concatenating strings together and making sure you have the right amount of spaces and all that kind of stuff and commas. But you've got these nice JSON documents to represent the queries too, which is great. Very easy to dynamically generate. So this makes sense. We might also want to add another way of filtering. Very easy to extend our model. We can add a new parameter to the API, and then add a new term to our query constraint to constrain also by brand. Easy enough. Product manager might come in the next day and ask for a price filter. This is a little bit more complicated because you've got a min and a max, and you also might want to sort as well. So it's getting a little more complicated. We're adding more and more to our API and our URL language here. And then you might come around and say, oh, well, I want to do a second sorting. And this is where it starts to get a little messy and ugly. I mean, if you look at this kind of language we're doing here and take a step back, we're basically taking what is a very nice and structured and easy to understand query language, and we're re-implementing it in the REST API. This is a very typical pattern that you've probably done yourself, right? But we're re-implementing it in the REST API, and it's not really a nice query language. It's kind of a shitty query language, SQL for short. Right? But what you'd really like to do, kind of like emotionally or morally before you actually think about it too hard, is what you'd like to do is you'd like to take this nice MQL query, and you'd like to send it down to the database through the API and said, Mongo, please execute this for me and send back the results. But as you think about it more, you realize that this is crazy talk, right? You'd be exposing your entire database on the internet. You'd have all sorts of security problems. You'd have all sorts of connection management problems. Your database is not meant to handle millions of connections from mobile devices around the world, right? So, traditionally you'd think this is crazy. But what we've done at Mongo, we've implemented this new service called Query Anywhere that allows you to do exactly that in a safe and secure way. And let me explain a little bit how that works. So what we give you is we give you a native SDK. So this is something that you would embed in your app. It supports, so there's a JavaScript SDK, there's a variety of languages, it supports iOS, Android, so you can do this in your mobile phone. And then what you can do is you can formulate a Mongo query and send it down through this middle layer, which I'll talk about in a minute, but let's for now say it's this magic that does some authentication and some access control to make sure that you're not returning data you shouldn't be returning to the wrong person. Runs that query in Atlas, running MongoDB, and then returns the data safely up to the browser. And what's going on is you're using the full Mongo query language. You've got this interesting authentication layer in the middle. And I'll talk about this for a second. It's not that the device is authenticating to the database or that you have some like database user 123. What's authenticating is the actual application user you have. So think about that for a minute. Like if you have an application, maybe you have another table somewhere that's got the usernames and passwords of those users. Right? If you tell Query Anywhere about that, Query Anywhere can use that to drive the authentication. Or maybe you're using Google Auth or Facebook Auth or something with OAuth or something through SAML. All of those will work. And what happens is once we know the actual application user, then we can follow a set of access control rules that you also define in this very cool declarative way I'll show in a minute to describe, well, for this collection, these users can see this data, but they can't see these fields, and they can write these fields, but they can't read these fields. And you can write these very sophisticated rules that allow you to ensure that only the people who are supposed to be able to do what they're doing can do what they're doing. All right, so I'll walk through an application to describe this in more detail. This is meant to be an application, a medical records application. We chose this because it's got some pretty sophisticated access control requirements and data privacy requirements. And this is a tool inside of Query Anywhere. This is a user interface tool. There's also a JSON equivalent of this, but this is a user interface tool that allows you to define these access controllers I talked about. So along the top, you have all the roles that a user might have. And what's interesting here is a role is not just defined as who your user is. Like when you log into your app, you're not always the same role. Your role is determined also within the context of the document you're trying to look at, which makes this really, really powerful. So up top, we have all these roles. And then along the left, we have all the fields. This is access controls for a particular collection. We have all the fields of the documents in this collection on the left-hand side. So things like basic info. This would be like your social security number, your birth date, things like that. Diagnostic codes. These are codes that insurance companies and doctors and nurses all use to communicate with each other. They're somewhat cryptic. Notes. Those are notes for maybe a patient visit. Prescriptions, those make sense. Vitals, these are your blood pressure, your heart rate, things like that. And so the way this works is you can go through for each role and say things like, okay, well for patient, a patient can read and write their own basic info, but pretty much they can only read the other stuff. Or a doctor has more privileges, right? They can read and write all sorts of diagnostic info and prescriptions and things like that, but you don't want to allow them to modify your social security number, for example. Nurses, similar. They can do a little bit less, but they can write the vitals. And then insurance agents, maybe they can just see your basic info and the diagnostic codes, right? And by doing this, you've now created a system where you really don't have a server, but you're doing full querying in a safe and secure way from your application all the way back to your database without having to write server code. So this is called Query Anywhere. It's new in 4.0. Query Anywhere is part of a new platform we have called Stitch. Query Anywhere is one of the many services along the bottom. I'll talk about most of these later in the talk. But this is our serverless platform for building modern applications. It's really, really exciting. And if you want to learn more about it, there's a talk track on this as well. Drew's giving a talk at 1 p.m. in Theater 4. So we encourage you to go check it out if you think this is interesting. OK, so we've got our documents in the database. One of the other things we might want to do with our data, which is very, very common, is create visualizations based on that data, or reports or dashboards that you can use to disseminate to people in your organization. And so we've done a lot in Mongo to help support this. I'm going to talk about a few features. The first is the BI connector. So the BI connector is a little proxy that speaks the MySQL wire protocol. And what it does is it converts MySQL SQL queries into Mongo aggregation queries, and then translates the data back. So if you have a BI tool that you know and love, like Tableau or Qlik or anything of that nature, you can now point that at your MongoDB data and get data out very, very easily. If you're pointing it at other relational databases, you can kind of do interesting things where you're looking at the data in tandem inside of Tableau or Qlik. This is also part of Atlas. So if you're hosting with Atlas, there's no setup to do for this. You click a button, and instantly the BI connector is set up, and you can instantly start talking to Mongo from one of those tools. So that's really cool. The other thing recently we built is an ODBC driver. So we like to joke around the office that all real business intelligence happens in Excel, and I think it's probably true. So you as a developer, you're used to using the shell and all sorts of fancy tools, but you might have folks in your organization that could really use some of that data in Mongo database in their Excel spreadsheets. And so with this ODBC driver, you can do that really, really easily. So we invite you to check that out. And then the last thing I'll talk about is MongoDB charts. So this is a new product. It's unlike the other products. With the other products, you're fundamentally flattening your nice kind of three-dimensional JSON data to make it work with these pre-existing tools. And for some things, that's exactly what you want to do, for example, like getting into Excel. But there are other times where it really makes sense to have a direct experience with the documents. And so with this tool, you can build really powerful visualizations using the document model. And this is also available in Atlas. So for anybody who's an Atlas customer, you can go into Atlas. There's this new Charts tab on the left. You can click on that. It's in beta, but you can start using it immediately. And you can build all sorts of beautiful visualizations. We've got this tool here that allows you to drag and drop fields onto this palette. And then you can also work with aggregation queries to get the exact data you want out of the database. And then you can use all sorts of different chart types. You've got bar charts, line charts, pretty much everything you'd ever want to use. And then you can take these beautiful reports and you can put them into dashboards and disseminate these to people in your organization. So this is a really cool tool. We've also got a talk on this if you're interested in learning more. Ben from our team is going to be doing this at 3 o'clock in Theater 1. So we encourage you to check it out if you're interested in charts. OK. So just going over some of the stuff we've worked on in documents. Asset transactions, probably the biggest thing we've done in the last year, really huge. The aggregation pipeline builder, so that's what we demoed earlier, makes it really, really easy in a visual way to build and debug these complex aggregation queries. Stitch Query Anywhere, so invite you to go to that talk. Really, really cool, very novel. Allows you to do all sorts of cool serverless things, which we really think is the future. And then all the analytics stuff we talked about, BI connector, ODBC driver, and charts. So if you remember in the beginning of the talk, I talked about several architectural pillars that make MongoDB unique and make MongoDB the best database for modern applications. The second we're going to talk about here is the fact that Mongo is a distributed database or uses distributed systems to give you a whole bunch of functionality you just can't get in a single node database. And to review what those are, one is high availability. This is the idea that your system could fail over to other nodes in the case of failure. Second is scale out, the idea of horizontal scaling. The third is workload isolation. And then the fourth, which I'm going to talk about in a little more detail now, is zone sharding. And as a reminder, what is zone sharding? Zone sharding is the ability to build global clusters with rules that say certain data should live in certain locations. And so, again, why would you want to do that, right? Well, number one, you want your data to be fast, for your application to be fast for everyone around the world, right? A lot of global applications suffer from the fact that while the app servers may be spread around everywhere, the database is in one place, and that's your bottleneck, right? Second thing is regulation, right? So things like GDPR and whatnot, right? Saying this data has to reside in this location, right? Zone sharding helps you with that. And to talk a little bit about more how this would work, I'm going to bring up this cool map. This is a map of the world. What you're looking at is we have one cluster deployed in the eastern United States. Let's pretend this is, US East or Virginia. And then the color coding on the map is showing what's the latency from that part of the world back to that database, right? So you can see, in the eastern US, you've got nice low latency, very fast data access. As you move further away from that, in the US, it gets slower. Europe's not so great. Asia, forget about it, right? Really, really slow access to your data. So what you might want to do in a scenario like this is you might want to add another cluster in Europe, right? And so this is great. Now all the folks in the US have fast access to their data. All the folks in the EU have fast access to their data. And in addition, like I mentioned before, if you're trying to comply with something like GDPR, you can ensure that the data for the European users stays inside of the EU, which is really important. I might then want to go add a third cluster over in Asia, right? We don't want the Australian customers waiting to, have traffic go over the ocean just to serve their application needs, right? So this kind of thing is what zone sharding allows you to do. And even though MongoDB has had this capability for a while, there's a lot of operational complexities in actually running this. And so what we thought would be cool is if in Atlas, this is our cloud-hosted MongoDB service, if in Atlas we made it incredibly easy to build these sorts of global clusters on any one of the major cloud providers. And to show you just how easy this is, I'm going to invite Melissa up to give a demo.
Hi, everyone. I'm really excited to show you what the team has built for you, so let's jump right into it. So we're going to start here in the Atlas UI, and I'm going to enter the Build a New Cluster experience. Now, there's a few features I'd like to go over first that are foundational to what we're going to be talking about with global clusters, so let's hit those first. We can select a target region, and I can deploy a cluster there. I can then move that cluster to a new region with just a few clicks with no changes in my connection string and no downtime. I can also go ahead and deploy across regions for higher resiliency, and I can add read-only nodes so that I can get low latency reads to my users no matter where they are across the globe. Now, these are all great, but we decided to take it up a notch, so let's go ahead and jump into our global cluster configuration. Now, you just saw this map. It's a beautiful, easy-to-read map, and what it's showing, again, is that the approximate write latency to our target cluster from around the world. So our target cluster is in Paris. So Western Europe has a great experience, right? Applications running quite smoothly. But in the Americas and Asia, those users are waiting. And what do users do when they wait? They leave. And when they leave, they impact the business. That's not going to be acceptable. So let's fix that. We're just simply going to enable global writes. Now, when we do this, we see we already got it across all three major cloud providers, so AWS, GCP, and Azure. We're ready to go there. And then we have two really easy-to-use templates. These are fully customizable. So you can change them as you grow and learn how this works. And in fact, what Will just showed you is this first global template. Now here we have a 3-geo global cluster already ready to go. So we have the America zone mapped to the North Virginia region, EMEA to Frankfurt, and APAC to Singapore. So the sun never sets in this configuration. We're doing pretty good, right? This is a great place to start, but as you change, your users move and grow, you're going to want to make some modifications to this. So I'm going to go ahead and make one. So I've realized that most of my APAC users are actually a little farther north, so I'm going to move my target region from Singapore up to Seoul. So to do that, all I need to do is come down here, select my zone, APAC, and then we're simply going to remap that to Seoul. And well, when we scroll up, we see this is already remapped. Now, the really cool thing is what this represents, which is all the automated stuff in the background. So we had a new cluster spin up in Seoul, right? Data's moving from Singapore into Seoul. And then that cluster in Singapore is taken down. You didn't have to do anything, no user intervention. We take care of all this complexity for you. You simply need to make that configuration. Now, let's go back into our template. And we're going to go into our excellent global performance. So we've made some modifications to our first template maybe over time, get something like this, or we start here. And this is pretty amazing because right now we're showing a configuration that gives a low latency write experience to the majority of the world's population. This is pretty impressive stuff. In fact, I've seen a lot of companies, try to do this with multiple teams, multiple years, phenomenal amount of work, just to get to something like this that we really consider table stakes now and provide this out of the box. And in fact, I'm going to try to zoom in here so I can give you a little better view. And we're going to show you something that I've seen so many people try to do, which is to have a map basically of both coasts, right? So you have your West Coast mapped to a region, Oregon here, East mapped to North Virginia. So your states and provinces in both coasts are having a great experience to your application. This is something you don't have to try to do anymore because it's already done for you. Now, once we go ahead and we click and we spin up our configuration, what's it look like? So let's go back over into our tab here. And we see that in our Atlas configuration, this looks like any other Atlas cluster, even a simple replica set. It looks exactly the same when it's a global configuration. Super easy to read interface. We can see exactly what's going on. And in fact, when we come down here to our connection string, we can get our connection string for our application. We see this is still the same simple, concise connection string. So no matter how complex our application is, no matter how sophisticated our application is, and how globally distributed it is, it's still the same simple, concise connection string. And actually, let me highlight that for you, in case you're like me, have a hard time seeing it in there. So we're going to throw that in our application, and we're going to start writing documents into our Mongo database. Now, you may be asking yourself, okay, well, that's great, but how exactly does Atlas know where my document should go in this beautiful map? So let's find out how the magic happens. Let's look at the actual data. And so to do that, we're going to go in the Data Explorer, another part of Atlas. And within here, we can go ahead and create our database. So let's do that. Let's see here. I'm typing a little slow because some of you maybe also have numb hands. It's kind of cold in here. So it's kind of hard to type with the numb hands. So we got hello instead of world. Let's go with globe. And then the next part of this is our shard key. And so half my shard key is already picked for me. This is great, right? I'm halfway there. I've got my location field, and we'll talk more about that in a minute, so that's super important. Keep an eye on that. Now, the second part of the shard key I need to pick. Of course, I didn't want to do this alone. I talked with my team, and we decided, okay, we're going to use user ID because that's got really high cardinality. We use it in a lot of our queries. This makes a great deal of sense. So I'm going to create my globally sharded collection and start putting documents into it. So I've got some documents in here already. You can see those up there. Now I'm going to highlight this location field again because this is where the magic happens, this one simple field. So all I have to do is set that location field in my application to either a 2-letter ISO country code or a subdivision code, and now that's what bakes in that location affinity. Now Atlas knows which zone that goes into. So this is MX, this is Mexico, so that's going to go in the Americas. Got another one here. We got lots of documents coming in. Okay, we got one for Germany. This is DE. That's going to go into EMEA. So we know exactly where these are going by our application writing that in. Now, as I'm going through here, I'm like, well, I'm doing pretty good. My application's growing. Getting a lot of users from India. In fact, from subdivision code, Rajasthan. So we can actually go back into our map and highlight that area and see exactly what their latency is like. Well, right now it's kind of dim, right? So those users are probably okay, they're maybe not super happy, but we want them to keep using our application, so let's increase their experience, make it better. We also notice this kind of border edge here, where these other zones are, that's kind of dim as well. So let's fix that. So instead of making a customization where we're changing what's there, we're going to add a whole new zone this time. So I'm going to come down here, I'm going to add my closest region. It's going to be Mumbai. And I come back up, and wow, those users are just having a phenomenal time, right? They love my application. They're going to start growing. Now, those border edges, you may go, well, what's happening there? And what's happening is what was formerly in EMEA and APAC, those documents are moving gracefully in the background into this new zone, right? Again, this is pretty amazing. I mean, think about this. This is all automatically happening. Like, you're just clicking on a map, and you're getting this kind of amazing experience. So now my users doing great. Now people want to travel the world, and they still want to access their data. So we want to go back and have those low latency reads. So all we need to do to configure that is click one button, really, actually one button. And now that's going to take a secondary from every zone and put in every other zone. So that as my users traverse the globe, they still have an incredible experience with my application. So what this means is that you don't have to be a household name internet brand in order to have this kind of low latency global configuration. You can really have a true real-time interactive experience regardless of borders across the globe. And Dallas, I really look forward to seeing what you build with this. Thank you.
Thank you, Melissa. Super cool demo. You know, for those who have tried to build something like this before, you know how hard this is. It's incredibly difficult. It's not just, the subtle thing here is it's not just about read latency, right? This is also write latency. Very, very cool. This is new in 4.0. So we invite you to check it out. It's just really easy to do with an Atlas account. Okay, so let's talk more about distributed systems and the type of things that you get from having a distributed database. We've talked a little bit before about high availability. This is the idea that if you have node failure, your application stays up because the workload, your database workload, is failing over to other nodes in your cluster. That's part of MongoDB. But on Atlas, we do some other things that are best practices to try to keep your uptime as high as possible. So for example, on the cloud providers that have availability zones like AWS, we will automatically on Atlas spread the nodes in your clusters across 3 availability zones. You really don't have a choice in the matter. It's just what we do as best practice. There are also other, there are other configurations that Melissa alluded to that you can add other regions, not just for the write case, but also for resiliency. So if you have a region in Virginia and you'd like Ohio to be kind of a secondary region in case the whole AWS region goes out, you can do that with Atlas. And so because of these things, we've actually just increased our availability SLA for Atlas to 99.995. This is an industry-leading SLA, uptime SLA. And it's our testament to you about how much we think you don't have to think about uptime. So the next thing, which I mentioned a little bit earlier in the talk, was this idea that real time is something that's very important for modern applications. The idea that you can react to events that happen asynchronously. And so when we think about what we can do with the database layer to make that easier, we added a feature called change streams. And what change streams allow you to do is it allows you to watch your database for changes and then react to those changes however you like. So here's an example of a code snippet. This is us watching a collection called My Collection. And we're watching for 2 types of operations, insert and replace operations, and further constraining that we're only interested in things where the value of n on the document is greater than 1. That's kind of arbitrary. You can do whatever you want. And then at the bottom, what we're doing is we're just kind of looping forever, consuming those changes, and then doing something with them. And this is incredibly cool. It allows you to kind of push this real-time stuff all the way to the bottom of your stack. So no matter how the data is changed, you're sure to capture it. But there's still some operational burdens with running things like this. So for example, you really have to make sure you don't miss a change if this code crashes, right? Or you got to make sure you don't deliver a change, the same change twice. Or you might have an enormous amount of change volume, right, that your app wasn't ready to handle. Can you auto-scale to handle that? So all of these things are things you need to do to make this kind of operationalized. And we've added something in Stitch, one of the other services that I showed you before, something called Stitch triggers. And you use Stitch triggers with Stitch functions. And what this allows you to do is kind of in a serverless way, build things like you would with that change stream manually, but do it in a serverless way that's auto-scaling and fault-tolerant and all that good stuff. And this is, like I mentioned, this is also part of our Stitch platform, 2 other services here. And the way this might work is, imagine you have an application and you send down to the database like an increment command. Maybe you're incrementing a counter, right? When you're using triggers, the way this works is it flows through the trigger system. So the trigger system sees the change you made. It then calls the corresponding function that you've associated with the trigger. This is a tiny JavaScript function that lets you basically do anything, and I'll show you an example of this in a minute. You could use that JavaScript function to make an API call, let's say, to Twilio, and then buzz someone's phone in their pocket, right? All in real time. So to show you this in a little more detail, I'm actually going to do the demo this time. Wish me luck. OK, let me see. Great, you can change to my screen. OK, cool, we're there. So here's the way this is going to work. I have here on this tab, this is an atlas. This is showing a particular collection in my database. This is the food database. This is the bar collection. I'm going to click on this here. And you're going to see a whole bunch of documents come up. I think the internet's a little bit slow right now. Let's see if this comes up. While I wait for that, I'm going to come over here, and I'm going to define a trigger. So this is a Stitch application that we've done nothing with yet. OK, we're back. We have some documents. I'm going to come over here, and I'm going to add a database trigger. And I'm going to call this maybe Dallas demo trigger. It's enabled. I will select the cluster that we were just looking at on the other tab. And the database name was foo. The collection name was bar. Let's watch just for inserts for this example. And then the meat of it is here. I'm going to select a function. The function's already written. I'll show it to you in a second, called my trigger function. I'm going to save this here. Great, so the trigger is defined. Let me go over to the functions just to show you what we're doing. So we've associated this trigger, like I mentioned, with a serverless function. You don't have to worry about where this runs. It's magic. It's going to run, and it's going to run in a scalable way. So if you need lots of these running, it will auto-scale up for you. And it's doing something very simple. It's just grabbing, for any of you who've written Mongo code before, this is very familiar. It's grabbing the database foo and the collection called counter. And this is a counter collection where we're going to count how many documents were inserted into the database. And then every time this trigger runs, it's just going to do an update where it increments that counter by 1. So let's watch this work for reals. I'm going to insert a document here. Doesn't really matter what's in the document. And now that I'm inserting it, the trigger is going to fire. And I don't know if you noticed, this counter collection wasn't here before. And if we look in here, it's got this one document, which is our counter, and the counter value of 1. If I were to go insert another document after this, the counter would increment to 2, and so on and so forth. Okay, so super, super easy. Triggers are, you can go back to the slideshow. The triggers are new in 4.0. So if you haven't tried them yet, we encourage you to try them out. Probably also talk about them in the Stitch talk that's happening later today. OK, so we've talked about a lot in distributed systems. Some really, really cool stuff. I don't want to make light of any of it. Global clusters is huge. Really, I struggle to find anything as easy to build global distributed clusters as with MongoDB. Really, really something that if you have a global application is something you should really check out. We've also, like I mentioned, increased our uptime SLA to an industry-leading 99.995. We talked about Stitch triggers. That was the demo I just gave you. All sorts of creative things you can do with triggers. Really, the more you think about it, the more your imagination gets going and all the cool things you can do with your app with triggers. So we really encourage you to check that out and think about all the cool things you can do with it. OK, so if you remember from the beginning of the talk, there were 3 architectural pillars that we felt made MongoDB the best database for modern applications. The third pillar is this idea of runs everywhere. And so, the first place you can run MongoDB, or at least we think the best place to run MongoDB, is in Atlas. This is our cloud-hosted MongoDB service. You can run on any of these cloud providers. A new thing there I thought I'd mention is we've just added a free tier to Atlas. So now you have a free tier on every one of the cloud providers. No excuse not to try it out for free. So we've got Azure, Google, and AWS. No credit card required. We really encourage you to check it out. And even beyond checking it out, it's great for development environments. It's great for QA and testing. We have an API that lets you spin them up and down. Really, really valuable. And our aspirations were not just to be able to do all this stuff on any one of the cloud providers, but we also want to enable you to build global clusters like Melissa demoed that even span cloud providers. So the same cluster with nodes in multiple cloud providers, right? And why would you want to do this? Well, there's a few reasons. The first is prevent lock-in, right? If you have a global cluster that can span multiple cloud providers, with one click, you decide that, prices are better on this cloud provider. Or this cloud provider now has some features and I want to switch. You could actually change cloud providers with zero downtime at the click of a button. Really, 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 really interesting. Really, really important. The other use case for this is to get regions in a cloud provider that might not be offered in your first cloud provider. So for example, let's say for a regulatory reason, you need to have 3 regions in a particular country in order to be compliant, and your favorite cloud provider only has 2. You can spin up a third with another cloud provider and meet that requirement. Or let's say that there's just a particular country you can't reach with one cloud provider just for latency reasons. You can then, in that global cluster, if you wanted to add something, let's say somewhere in India, and Amazon didn't support that, you could go get that on Azure or Google and be off to the races. And then finally, another interesting use case is you might be really happy with, let's say, AWS. But let's say Google comes out with a machine learning service that you really, really want to use. And you want to be able to have that machine learning service have low latency access to your data. And so you want to actually put a node in Google that is secondary, where the data is kind of magically replicating from the cluster over to Google and is really physically proximate to that machine learning service to provide the best low latency experience for that. So this is not available yet. This is coming soon. This is going to be available, we're targeting early next year. OK. Another thing we're seeing, even though more and more we're seeing a lot of workloads move to the cloud, we're still seeing, obviously, workloads in the private cloud. And people there are often using Ops Manager, which is our management software for MongoDB on-prem. And we're also seeing this trend where people are tending to manage their application using Kubernetes. I don't know how many folks here have started to dabble with Kubernetes. But if you're using that on-prem, you'd like to be able to provision your MongoDB clusters with Kubernetes and have a really integrated experience. So we've done a tight integration between Ops Manager and Kubernetes. So now you can actually run MongoDB on your Kubernetes cluster. And through Kubernetes commands, you can provision, upgrade, do all sorts of things in a very Kubernetes native way. If you haven't seen this announcement, we suggest you go check it out. Anyone who's using Kubernetes, this is a great way to bring MongoDB very easily into your Kubernetes infrastructure. Finally, the last thing about runs everywhere. So one thing that's eluded MongoDB for a while, and I'll motivate it with this example, is the ability to run in a mobile device. Right? So let's look at this code right here. This is some Java code. Let's pretend this is running on a server somewhere where you can run Java. What is it doing? Well, it's pretty simply just reading a barcode, and then it's maybe incrementing something in the database. Maybe it's counting inventory of a certain item, things like that. And if you were to write this on a server somewhere, and you might have somebody in a mobile device in a warehouse scanning barcodes, talking over to a REST API, this is what you're using to save your data into MongoDB. But as we know, a lot of those environments where you do this sort of stuff are not the best network. You don't have the best network connectivity, right? So we asked ourselves, well, wouldn't it be amazing if you could take this exact same Java code and run it in your mobile device, writing to a MongoDB instance, an embedded MongoDB instance on your mobile phone. And that's what we've just allowed you to do with MongoDB Mobile. So we've just released MongoDB Mobile, and this allows you to have the same exact experience you would have on the server side, on a mobile device. If you're doing things with APIs in mobile, which is very likely, and you have JSON data you're getting in a mobile setting, and you want to save that back to the database inside the mobile device, you can do that very, very easily now. And of course, no mobile solution would be complete without the ability to then sync data back to a central database. And so we've also introduced this feature called MongoDB Sync. And it's quite sophisticated. It doesn't just stupidly sync the data. It actually gives you control over how data syncing works. So for example, depending on what the data is, you might say, oh, I want the last write to win, or I want the first write to win. Or maybe if two conflicting writes occur, you actually need the user's help in resolving the conflict. And so basically with the SDK, you can call this collection.sync on individual documents and provide a conflict resolution function that would allow you to do whatever you want. You might pop up a little modal dialog to the user, asking them to pick which wins or to re-input their form, whatever makes sense for your application. And the way it works under the hood is we're actually using the change streams functionality I talked about earlier and Stitch to bidirectionally sync data. So as changes happen in your Atlas cluster, they're being synced to the mobile device. And likewise, in the other direction, changes in the mobile device are being synced back to the Atlas cluster. So this is new and now in beta. So you can go online, check it out. We'd love feedback. OK, so talked a lot about kind of the runs everywhere mantra of MongoDB. We talked about cross-cloud, not available yet, but it's coming very soon. This is going to be huge. I don't know of any database that can do this, frankly. Kubernetes, we have a nice Kubernetes integration. We really are excited about the Kubernetes ecosystem and all the cool stuff that's happening in the Kubernetes community. So we're excited to be integrated with that. We have a free tier on every public cloud now. So we just added Azure. So if you're an Azure user and you were waiting for a free tier to try it out, we encourage you to go do so. And then finally, MongoDB Mobile and the mobile sync technology. OK. So we talked about a lot today, a lot of really cool stuff. Probably a little overwhelming. But with Stitch, I'll go through kind of each of these. With Stitch, Query Anywhere, we really think this is, while a little bit mind-bendy, the future of how applications are going to be written. Serverless is a really interesting movement, and we think we're doing some pretty unique and novel things in the serverless space. So please check that out. It's got functions, it's got triggers, it's got all sorts of stuff that even with other serverless frameworks you might not have seen because this is very database-centric. Mobile sync beta, like I just talked about, allows you to sync data back and forth between a MongoDB mobile database instance and a backend. Really, really awesome for any of you who are mobile app developers out there. Global applications. I didn't talk about this previously, but this is something that marries with the global clusters that Melissa talked about in the demo. So with global applications, you can now write Stitch applications, Query Anywhere type of applications like I showed you, that actually take advantage of those globally distributed clusters with a globally distributed app tier that you don't have to manage, but is making sure that all of your applications are fast for users around the world. And then, of course, another feature we added, which is kind of to round out the experience, the ability to attach multiple database clusters to a Stitch app. OK, cool. So Atlas, a whole bunch of new stuff there. Remember, Atlas is our cloud-hosted MongoDB service. So we talked about charts, right? MongoDB native charts. You can interact directly with your MongoDB documents and build beautiful visualizations. Really, really cool. Global clusters, very exciting. Again, I've really seen nothing that can do this quite like global clusters can. It's very, very powerful. Users around the world are starting to demand fast latency access to their data. Atlas really helps you do that easily. Like I mentioned, free tier on every public cloud. Enterprise security features. I didn't talk about this before, but there are a bunch of new enterprise security features in Atlas. So for example, if you use LDAP to manage your users in your organization, Atlas can use that LDAP system for authentication. And there are also some interesting security features around encryption at rest. So you can now bring your own key store. So if you're using KMS on AWS, you can give us the key store. You can let us use the key store, and then you can revoke keys, really have a good security experience in that way. We talked about our SLA. We've improved it recently. We really believe that you do not have to worry about downtime with Atlas, and we've backed it with our guarantee. And then, of course, in the core MongoDB engine, we've also done a lot of great stuff. So new driver, very exciting. I don't know if there's folks in the Go community out there, but we have a new Go driver in beta. And if you're a Go programmer, we'd really love to get your feedback on that, so please check it out. Query enhancements, so I talked about our aggregation framework and all the operators we added around date manipulations and type conversions and things like that. Free monitoring, I didn't talk about this before, but this is really exciting. So now, if you're using MongoDB in 4.0, you can get, and you want to get statistics out of the database, see what's happening in the internals. You can just turn this on with the Mongo shell, and the database will start exporting to you all sorts of metrics to help you monitor, absolutely free. And then last but not least, perhaps the most exciting thing that's happened in the last year to the core database is multi-document, multi-operation transactions. Again, something that is one of the things that gives the traditional database much of its power. And now that it's in MongoDB, it makes MongoDB equally as powerful, maybe more so. And so, all of these things are centered around, making MongoDB the best database for modern applications. It's dubbed a NoSQL database, but we truly think it's a horizontal platform that is great for any use case, whether it's e-commerce or it's enterprise or it's consumer. This is the database you want to use for your next application, and we couldn't be more excited about our future plans for it. That's the end of the keynote for today. Thank you for coming. I'm going to be hanging out all day, so we'd love to see you, hear how you're using MongoDB, get any feedback you have. I'm going to turn it back over to Richard to close it out.
Thank you, Will, and Scott and Melissa for those demos. Well, folks, I think that counts as a ton of new capabilities that we've been adding to MongoDB over the last year and change. What do you all think? Thanks again for covering all of that. So we're about to break for a bit, but before we go, I want to remind everyone, or in case anybody didn't hear at the beginning, toward the end of the day, you should check your inbox. After the last breakout session, you should be receiving a feedback survey. Please do fill out that survey in order to be able to pick up your swag at the registration booth out in the hall. I would also like, before we break for lunch, to invite everyone at the end of the day to join us for a happy hour in the Vetted Well outside. And then just want to say lunch is now served out in the auditorium. Seating is available in the Vetted Well and in Theater 1, and we'll be picking things back up at about 10 after 1. Thank you.